Today we're going to take a look at how can we describe a line in a little bit more detail, and specifically how can we describe a pattern. Okay, so when we talk about a line, we're always talking about a pattern that we're trying to describe and trying to come up with a way of describing it, and again, it's going to be mathematically. Now let's remember that each linear function, okay, or straight line on a graph, can be described by some equation. Okay, it can be described by an equation. An equation is going to be something that helps us to figure out what that pattern is between two numbers, between an x value and a y value. If the slope is given and the y-intercept is known, then we can use graphic form to describe the graph. Now, when I say when the slope and the y-intercept are given or they're known, it just means that we can actually either solve for them or they are in fact given to us and we have them right there. What does it look like? Here's graphic form. Y is equal to mx plus b. Okay, y is equal to mx plus b. Now, the x and the y are any point on the line. Okay, for the sake of the form, we're going to keep them, they will always be left as x and y. Okay, so they represent some point. Okay, so y and x are equal to some point x, y that's on the line. Okay, it's any point that's along the line. In fact, it could be the y-intercept, the x-intercept, or any other value that makes this whole thing work. The m value, okay, so here's our m value right there, is the slope of the line. Okay, we're going to leave it as a fraction or whole number, depending on what we're given. Okay, remember that slope is also our rate of change. So if we're also given something that's given as a rate of change, we can use that as well. It could be a decimal. We can gladly put a decimal there, but if we have it as a fraction or whole number, we'll try to keep it like that. Okay, like I said, decimals are not usually used. Okay, but they can be. It's not to say that they can't be. They can. It's just we try to use a fraction as often as possible. Then the b value right here, there you go, there's a b value, is the y-intercept. Okay, in the coordinate point, it has a value 0y, and this value right here is our b. Okay, so whatever the y value is there, that's going to be our b. And that's what we're going to use as our b value. Okay, so we need to know our m and our b, and when we know that, we can use those to create some sort of equation that represents our line. So let's do a couple of examples, and let's take a look at how we can use graphic form to represent it. By the way, it's also called slope-intercept form because we know our slope and our intercept, but I like to use graphic form. I will always try to use graphic form. Now, the graph of a linear function has a slope of 3 over 5. Okay, this is our slope, so that's m, and a y-intercept at -4. Okay, there's our b. Let's write an equation for this function. Well, our general form is mx plus b. Y is mx plus b, and so we're going to put them in 3 over 5x plus -4. But if we're adding a negative, we can write that as y is equal to 3 over 5x minus 4. So we'll leave the plus sign out of there. It's either adding a negative or just subtracting that number. It's both the exact same thing, so we don't have to really look at the difference in that. Okay, so if we're given the slope and we're given the y-intercept, that's what we're going to do. Okay, and in some questions, that's exactly the way it's going to be. In other questions, we're going to have something like this, where we actually have to solve for our slope and figure out what our y-intercept is. Well, in this case here, this is our y-intercept. Okay, this is the point 0, 2. So our b value is going to be 2. Then we're going to look at our slope. Now remember, the slope is between any 2 points along the line. We have lots of points here. We're going to say that these are all points along the line. Okay, that's the way it's supposed to be at least. Now we can choose any 2 points along this line here. Okay, absolutely any two. I'm going to take this one here, and I'm going to take the 2 intercepts like that. We have a rise of 2, a run of 4. Our m, again, is rise over run. Rise is 2, run is 4. 2 over 4 is equal to 1/2. And that is our slope. Okay, so we have a b of 2 and a m of 1 over 2. So our equation is going to be y is equal to 1/2 x plus 2. Now, we talk about domain and range as well. So what is the domain and range of this function? Well, because it's just everything is available, we're going to say that x could be a part of the real number system, so everything, and y is also a part of the real number system because every value of x and y is possible because this goes on and on and on forever. All decimals, all negatives, all positives, everything will in fact work. Okay, but this is our equation here. Now, just to quickly let you know, any one of these points can be found in this equation. So let's say that we know that x equals 6. We can do y equals 1/2 times 6 plus 2. And that is y is equal to 5. So we have the point 6, 5. 6, 5 is right here. It's on the line. Okay, that's another point that is along the line. So we can check it with our equation. Now, what if we're given the equation and we want to graph something out? We can do that as well. So in this case here, we have the equation y is equal to 1/2 x plus 3. And in this case, and what we have is our m value, which is being multiplied to x, and our b value, which is being added on at the end. Now, as long as we keep everything in this order, okay, we'll have it in graphic form, the y all by itself, and then the x term first, and the constant second, and we have it in that form. All right, so m is equal to 1/2, b is equal to 3. So what we're going to do, and now I'm going to quickly label this graph here. We have 2, 4, 6, 2, 4, 6, -2, -4, -6, -2, -4, -6. Whenever we're graphing something out, we need 2 points. The first point we have is our slope, or sorry, our y-intercept of 3. So we have this point right here, 0, 3. That's going to be a point on the line. The second point we can find is using the slope. Okay, so from our first point, we're going to have a rise and a run. A rise of 1, a run of 2 to this point here, which is at 2, 4. Now, we could find every other point using that same slope, or we could understand that because it has the same slope, we're going to have this line that goes through here. And this is the equation y equals 1/2 x plus 3. Now, we're going to pause here. For those of you that are in my class, you can take a look at the assignment. Okay, so it's LI.04, and you can start working on questions 1 to 3.